Hello my dear students, this is Reema. So today we will be studying the equations of motion of the chapter motion of science class 9. Okay, so those who have not subscribed to my videos, please do subscribe to my videos, and also please don't forget to click on the bell icon to get notified of my future videos. Okay, so let's start with the equations of motion today. So there are actually three equations, okay? The first equation, second and the third equations of motion. The first equation of motion is V is equal to U plus AT. Okay, this is our first equation of motion. Very important topic, okay? You will get so many numericals to solve related to these equations, okay? So just learn all the derivation, and also I will show how to derive it using the graphical method. Okay, so the first one is V is equal to U plus AT. Actually see here the final velocity is equal to initial velocity plus acceleration into time. Okay, so this is what actually here velocities are given and time is given. So this is actually it describes the velocity time relation. Okay, this is the this equation shows the velocity time relation. Okay, and our second equation of motion. So second equation of motion. Second equation of motion is what? S equal to ut plus half at square. See, S is equal to ut plus half at square. See here, S means what? Displacement and time. Okay, displacement is equal to ut plus half at square. So this equation shows which relation? It shows the displacement time relation. Okay, so this is the second equation of motion, displacement time relation. It shows, you can also say position time relation. Okay, and then the third equation of motion is 2as is equal to v square minus u square. See here, velocity and position. S is position, that is displacement. So it shows what? Displacement, velocity relation. Also you can say position velocity. Okay, position displacement. Okay, position time relation is the second equation, and third one is position velocity relation. So now we'll see how to derive. So derivation of equations of motion. Okay, so first, for deriving the equations of motion, we need to keep in mind certain equations. You know what is the equation of acceleration, right? Acceleration is what? V minus u by t. And also, what is the distance equation? Distance is what? Distance or displacement. S is what? Vt. Speed into time, velocity into time, right? So also, if our velocity is not constant, okay, if our velocity is not constant, then how can we, if velocity not constant, then instead of velocity we have to take what? Average velocity. So average velocity replaces velocity. Okay, so the first equation of motion we have going to derive. So for this, you know what? Acceleration is equal to v minus u by t, right? So we have to find what is the final velocity. So what? V minus u is equal to what? A into t. It's division, it goes there, it becomes multiplication. AT. So what is V? V is equal to AT plus U or U plus AT. So this is our first equation of motion. So we have derived it from our acceleration. So now we are going to derive the second equation of motion. So we know that what is displacement? Displacement is equal to velocity into time. So what is S? S is equal to Vt, right? So if our velocity is not constant, then instead of velocity we have to take average velocity, right? So this will be what? Average velocity into time. So what is average? Average, so average, okay, sorry. We say V average into time. Okay, so what is average velocity? Average velocity is what? V plus U by T, by 2. V plus U by 2, that is our average velocity. So S is equal to V average into T. We'll replace V average by V plus U by 2. That is V plus U by 2 into time. Now we'll see how much it will be. Vt plus Ut by 2. That is equal to S. Okay. And now what is our first equation of motion? The first equation of motion gives what? V is equal to U plus AT. Okay. Now we have V here. So instead of V, we substitute this one. Okay. So S equal to, instead of V, we substitute U plus AT, then T into T plus UT by 2. Right? So here we have UT, we are going to open the bracket, UT plus AT square plus UT by 2. Right? So how many UT we have? 2 UT. 2 UT plus AT square by 2, which is equal to 2 UT by 2 plus AT square by 2, right? So this will get cancelled. So what is S? UT plus AT square by 2 is half AT square, and this is our second equation. So this is how we derive our second equation. That is what displacement is: velocity into time. And if the velocity is not constant, we are going to take the average velocity. Average velocity is what? V plus U by 2. So S is equal to V plus U by 2 into T. That is Vt plus Ut by 2. And instead of this final velocity, we'll substitute the first equation of motion. And then we got our second equation, that is S is equal to Ut plus half At square. Right? Now we will be deriving the third equation of motion. So here also we have to start from the displacement. So the third equation of motion. So displacement is equal to velocity into time. So if the velocity is not constant, we have to take what? Average velocity. So displacement is equal to average velocity into time. Right? So here average velocity is what? U plus V by 2 into T. So here from the first equation of motion, we know V is equal to what? Final velocity is equal to U plus AT. Right? This is our first equation of motion. So here we have U plus V by U plus V by 2 into T. So this T we have to replace. Okay, see a t we have to substitute. So we'll take the t. We'll derive the t from this equation. So at will be is equal to v minus u. So what is t? T is v minus u by a. So we'll substitute t is equal to v minus u by a here in this t. That is s is equal to u plus v by 2 into v minus u by a. You know that this is v plus u into v minus u. What is v plus u into v minus u? Which is equal to v square minus u square. 2 into a is 2a. So we'll take this term to the other side. So it will be 2as is equal to v square minus u square, and this is our third equation. Okay.